Okay. Hello, everyone. Welcome to my session for today's DevTalks Community Day. So, as you can see, today's session is on using or leveraging Google's MLKit for high-performance OCR. So, for those of you who don't know me, my name is James Swinton Bland. I'm the developer advocate for EMIR here at Zebra Technologies. I've been with Zebra for almost 3 years now. As a developer advocate, it's my job to work with partners, customers, end users, and help them to get the most out of our technology, our software, SDKs, and our hardware. So this is the, here we go. This is the agenda for today's session. So the first thing I want to do is just give a very brief and high-level overview of OCR. So I appreciate many of you on this webinar will be familiar with OCR, but just to make sure we all start on the same page from the same footing, I'm just going to go over this at quite a high level. So we'll talk about very quickly what it is. We'll touch upon how it works. Again, at a very high level, we won't get dragged into the weeds with the detail. And then we'll look at some common application areas, specifically from an enterprise point of view. So application areas of OCR. Then we'll actually move into more of the meat of the presentation. So we'll go and give an overview of MLKit as a whole. So what it is, how it works, and what APIs are available within MLKit. We'll break down some of the concepts there, and then we'll take a step into actually using MLKit. So how, as a developer, would you take this SDK and leverage it to use it in your applications? So we'll go through a developer flow. We'll take a look at a very simple code sample just to sort of show you how easy this stuff is. I'll talk through some best practices for using MLKit in real time, so best practices for real-time performance. We'll touch upon using custom models with MLKit, getting a bit ahead of ourselves there. We'll come to that towards the end of the session. And then I'll just finish off with some live demos. So we'll go through the official demo from Google, and then I'll show you something that I've built using some Zebra hardware that puts maybe more of a real-world spin onto things. So without further ado then, let's go and have a look at the OCR overview. So what is OCR? So very simply, OCR, or optical character recognition, is the use of technology to distinguish printed or handwritten text characters inside digital images of physical documents, such as a scanned paper document. So it's essentially taking physical documents and turning them into digital documents by decoding the text inside that document. Very simple stuff. So how does it work then at a high level? So obviously the first thing that needs to be done is some sort of image needs to be captured. Once that image is captured, it's then converted into a two-tone image. So typically this will be a black and a white image. The image is then analyzed. So this converted two-tone image is analyzed for light and dark areas. So the dark areas are deemed to be the characters that need to be processed further in order to be recognized or decoded. And then the light areas are what's deemed to be the background. And then this is ignored or excluded from any further processing. So those dark areas are then sent for further processing. And there's typically two techniques used here for this further processing. We use something either called pattern recognition, or we use something called feature detection. So what are these two things then, and what are the differences? So pattern recognition is a technique that attempts to match characters to a matrix of characters that are stored in a database. So this is quite a rudimentary way of performing OCR. Essentially, when you have a character in front of you, or you place the character in front of this pattern recognition software, it will take that image of that character and try and compare it to every single character that it has inside of its database. And then the one that it has the highest confidence in a match, it will deem it to be that calendar. So if I have a picture of a letter A, it's going to compare that to every single letter in its index. And then it will come back and say, I think this is letter A. So obviously, this is quite a rudimentary way of doing things. It's quite a legacy way of doing things, shall we say. It's still in use today, and it relies on input characters being a consistent font. So things like OCR-A and OCR-B. I think OCR-A was originally introduced in the 60s or around about then. So it's quite an old data technology, but it's very useful for when you have firm control over the document that you are trying to perform OCR on. So if you have a passport or a driving license or something like this, where the format is always the same and you have control over what fonts are used, then it's a nice simple way of getting very reliable results. If you want to do things with maybe more of a broader brush, then you're going to have to use feature detection, which is a much more sophisticated recognition method. So rather than just trying to do one-to-one matches, feature detection will decompose the characters into their base features, so the things such as like lines, loops, and intersections, and then it will take this information about those features, pass it through some sort of algorithm. So for example, the MLKit SDK APIs will leverage machine learning algorithms. It would pass it through one of those algorithms in order to determine what that feature is and what that character is based on those features. So in terms of some application areas then, I've just listed some of the very common ones. This list is by no means exhaustive. So the most obvious use case for OCR is just the scanning of documents. So indexing print material for search engines, for example, or just automating data entry, extraction, and processing. Banks are regular users of OCR as well. So electronic document processing, if you think of things like checks, when you go and make a deposit at a machine, you don't have to interact with any humans, but the machine knows what's on that check. It's because the machine is performing OCR, and it will use standard pattern recognition in order to match those fonts to its database of fonts. ANPR and transportation. So from a UK view here, I know our police use ANPR, automatic number plate recognition systems, in order to read license plates as the cars are driving across the road. And then they're checked against a DVLA, or driver's license agency database, to make sure the car is insured and the person driving has a license, and so on and so forth. Logistics, so sorting letters for mail delivery is a very common use case. And I'm sure we can all think of lots more use cases as well. So things like translation, accessibility, and archiving are all very common areas and use cases for OCR. So that's OCR as a whole sort of covered off. So now let's talk more specifically about MLKit. So what is MLKit? So MLKit stands for Machine Learning Kit. And it's essentially a mobile SDK that brings Google's machine learning expertise to Android and iOS apps. So it's a mobile-centric SDK. It's available on Android and iOS. I'm only going to talk about the Android side of things in today's presentation, but it's also got all of these features available for iOS. And this SDK essentially combines all of Google's machine learning technologies. So you may have been familiar in the past with their Cloud Vision APIs, their Mobile Vision APIs, and also TensorFlow. So the Cloud Vision APIs were sort of the precursor to MLKit, where they had this software running in the cloud. Mobile Vision was the counterpart to that, where some of the simpler use cases could be achieved on device. And TensorFlow is a piece of software that you can use to create custom machine learning algorithms, or models, I should say, for your specific use cases. So it combines all three of those things and puts them all into one SDK. So the Cloud Vision and Mobile Vision APIs are now incorporated into MLKit, and you can leverage TensorFlow for the you can leverage TensorFlow custom models in order to perform your character recognition, or whatever it is that you want to recognize in your use case. So just some more detail on what MLKit is then, and this is information pretty much taken from the landing page of the MLKit developer site. But something to drive home here is that it's optimized for mobile. So all of MLKit's processing now happens on device. So none of the information needs to go up to the cloud, and you don't need to have an internet connection. So this makes it really fast, and it unlocks real-time use cases. So if you want to use the camera input and then perform OCR, or optical character recognition, live in real time using that camera input, it can do that because there's no bottleneck of having to go up to a cloud server somewhere for the processing. And of course, by virtue of it happening on device, everything works offline. So that's very good from a bandwidth and a cost and time perspective, but it's also very good from a privacy perspective. So if you have images or text that you need to be certain don't go anywhere outside of your ecosystem, then MLKit's going to still allow you to achieve that. So it's very easy to use as well, and I can attest to this. Google combine best-in-class machine learning models with advanced processing pipelines and offer these through easy-to-use APIs to enable powerful use cases in your apps. So it's a very marketing-heavy couple of sentences there, but I do agree with the key point. It is very easy to use. It takes what can be quite a complicated subject, and the APIs essentially just say, here, take this and give me what I want from it. And we'll see that that's the case in practice in just a few slides' time. And of course, finally, it's built with Google's expertise. So we're all aware that Google's a huge company with, lots of really talented employees there. The software that Google tends to produce tends to be quite robust, well-developed, and efficient. So how does it work then at a high level? So there's sort of two different ways that you can leverage MLKit. The easiest, simplest, and beginner way of doing things is just using their base APIs. So we'll see in the next few slides what APIs they have available to meet certain use cases. But these base APIs are what's included within the SDK, and they're backed by Google's models. So Google have a collection of machine learning models that they've developed. And these are used to perform simple use cases. So as far as the developer is concerned, you can get up and running with MLKit, and you don't even need to know what's going on in the background. You don't need to have any machine learning knowledge. You don't need to know about models or anything like that. The second way that you can use MLKit is by using custom models. So as I mentioned before, Google have a piece of software called TensorFlow. And this allows you to create your own models, and then you can use those models for complex or unique OCR use cases. Those models can be fed into MLKit, and then those models can be used to perform the recognition that you're after for your particular use case. So we'll touch a little bit more upon that in the next few slides. But before we do, let's have a look at the base APIs that are on offer. So there's sort of two categories of base APIs they offer. The first category is called Vision APIs, and this is for things like objects, text, and barcodes. We'll go through the individual ones. And then the second set of APIs they offer are called Language APIs. So these are more for distinguishing languages, just doing translation, and so on and so forth. So the first set we'll talk about, and this is where there's a few more APIs, is the Vision APIs collection. So the first API that they have available is for barcode scanning. So I know there's lots of different SDKs that do this, but obviously Google offer their own one. It just simply allows you to scan and process barcodes, and it supports most standard 1 and 2D barcode formats. They also provide facial detection, so detecting faces and facial landmarks. They provide a very simple to use API for that. Object detection and tracking, so this being able to localize or identify an object in an image, and then being able to track that either through a series of images or through a video feed. Text recognition as well. Obviously, this is the bread and butter of OCR applications, so of course it performs text recognition. We have APIs for image labeling as well. So from my experience, this isn't the most effective API, but it does certainly work, and it's certainly interesting to see it in action. But it allows you to identify objects, locations, activities, animal species, products, and so on and so forth. You can use a general purpose base model, which is what I've been using, which is why the image labeling is probably a little bit off. I mean, it will detect my computer mouse as a mouse, for example, but then it also thinks it's a book at the same time. But you can use the general purpose models to get results like that very quickly out of the box, or you could tailor it and you could write a custom TensorFlow model, and then I'm sure you would get much better image labeling results because you'd be able to train that model for the particular objects that you're looking for. Pose detection, so this API is actually in beta at the moment. We'll show you a demo of this towards the end of the presentation, but it allows you to detect the position of the human body in real time, which is quite interesting. Digital ink recognition, so being able to recognize handwritten text and hand-drawn shapes on a digital surface, such as a touchscreen, and it recognizes over 300 languages, also recognizes emojis and some basic shapes. And then finally, selfie segmentation. So being able to cut the background from a user within a scene and then just focus on the actual selfie part. So as you can see there on my camera, pretty much what that piece of software is doing. Google have an API to do the same sort of thing. I'm just going to double check here. Yeah, okay. So the second set of APIs that they have are natural language APIs. So there's 4 APIs under this umbrella. The first one is called Language ID, and it does pretty much what you would expect. And this allows you to determine the language of a string of text with only a few words. So long as you have about 3 or 4 words in your string, you can use MLKit to determine what language that actually is. So that can be really useful for sort of the Sanskrit languages, where it can be quite hard to determine which region or country they're from if you're not actively familiar with that culture. On-device translation as well, so being able to translate text between 58 languages. Obviously, this has been around for a long time, but now it's available entirely on device, so nothing has to go up to the cloud. It can be really useful for use cases where you might need to perform language translation, but you don't have an internet connection because you're too rural or something like that. Smart replies. So if you're an Android developer, you're probably familiar with this already. The Android OS uses this to generate inline replies for your notifications, but you can use it inside your applications to generate reply suggestions in text conversations. And then finally, entity extraction. So being able to detect and locate entities. And when they say entities, we mean things like addresses or date and time, phone number, and so on. And then take actions based on those entities, and that works in 15 different languages. So we can see there, I haven't mentioned every single API that's available, but there are quite a few different APIs. I think there's around 12 different categories of APIs from the top of my head. So hopefully we've got a good understanding of what OCR is, at least at a high level. And now hopefully you'll at least know what MLKit is about at a high level as well. So now let's take a look at actually using MLKit from more of a developer's perspective. So how does it work then? So I'm just going to click through these next few blocks, and each of these blocks is sort of a step that you would have to take in your application, a piece of logic that you would have to write. There's a few steps, but it is very simple. And in the next slide, I'll show you the code snippet that basically puts this into action. So the first thing you need to do is you need to prepare an input image. An input image is just a class from MLKit. This input image takes a base form of media, or it takes an input, a parameter, I should say. It takes 4 different parameters depending on your use case. So you can use the media.image, you can use a bitmap, you can use a file URI if you are loading it from the file system, or you could use a byte buffer or a byte array. So you pass through that core content, let's just say a bitmap, for example, you pass that through and you create an input image. Once you have that input image, you then need to create an instance of the text recognizer class. So for this use case, I've just picked the simplest one, and that's just for recognizing text, not to worry about face detection or anything like that. If you want to use some of the other APIs, they have different classes for the different detections. So if you want to perform barcode decoding, for example, you would start up, or you would initialize a barcode recognizer instance. But for this use case, we're going to be detecting text. So we'll initialize the text recognizer instance. Once we've initialized that, we then just need to basically pass the input image that we created in step 1. We need to pass that through to the text recognizer instance and just call an API called process and ask it to process that image. Once that image has been processed, this will happen asynchronously. So you need to pass through an interface where you can get a callback to let you know that that's done. Once that's done, you'll be returned a text object, and that text object contains the full text as the result. So that would just be one long string with your text result. And it will also include what are called text blocks, and it will include one or more of these text blocks. So each text block is a rectangular block of text, which can then contain one or more lines. So then we can extract the elements from those lines. And those lines are essentially the elements within those lines, I should say, are essentially the words or word-like entities, such as dates. So once we've processed that image, there's 3 more steps to take. We get the entire text back, and we need to break that down into its individual text blocks. For each text block, we need to get the line from it. And then from each line, we need to get the elements from that line. And those elements are what make up that text block. So I think that's maybe a little bit confusing just looking at the flow diagram here. So let's put that into a little bit of practice. So this is on the left-hand side here, the first 3 steps of the previous slide. So the first thing we need to do is create our input image here. So we're just loading this from a media image in this case, providing through the rotation of that image. We're then initializing our instance of the text recognizer. So again, this is just a very simple one-liner. We're just calling getClient on the text recognition class. And then we're attempting to process this image. So we call recognizer.process, and we pass through this input image that we created. And then we add our callback here, so our onSuccess listener, which will be notified when the text is decoded, or our onFailure listener, which will be triggered if something has gone wrong. But of course, just for now, we're going to assume that everything completed successfully. So we'll be returned this text object here called vision text. And this is where we can go and do the next, or the final 3 steps that are on the previous slide, with extracting the text blocks, lines, and elements from this text object. So over here on the right, this is just our process result method that we called in the onSuccess. I made an error there. I didn't pass through the parameter, but no worries, this didn't get compiled anyway. So this is the method for processing the result. So we get our string from the result by just calling getText. Then we need to loop through all the different blocks, and then inside each block will be 1 or more lines. So we loop through the lines, and then inside each line will be 1 or more element. And then this element text is the individual pieces of text that MLKit has identified within that image of text that you have passed through. So I think that's all about maybe 30 lines of code, something like that, maybe a little bit less. And essentially, that's pretty much all you need to do. You need to obviously include the SDK in your Gradle or inside your project somehow, but that's all standard prerequisites. And then you can go from having never done OCR to having very efficient OCR in pretty much 30 lines of code. So I said I would talk about some best practices for real-time performance. So this is where we're going to do that. So MLKit is compatible with the Camera, Camera 2, and Camera X APIs. There's a couple of different best practices that you want to adhere to, depending on which API you're using. So if you're using the Camera or Camera 2 APIs, which I guess are sort of legacy APIs at this point, then you want to make sure that you throttle the calls to the text recognizer. So essentially the recommendation from Google is if text recognizer is still busy processing the last frame when you've received a new frame from wherever your input is, Camera or Camera 2 APIs, then just drop that frame essentially. They also recommend for best performance to capture images in the YUV 420 888 format. Alternatively, if you're using the Camera X APIs, the recommendation is pretty much to do the same thing, is to drop frames if the text recognizer is busy processing the frames when you have a new frame ready. But Camera X APIs do this for you, basically, provided that the back pressure strategy is set to strategy keep only latest. We also recommend capturing images in the NV21 format, and to improve general performance, you want to capture images at the lowest possible resolution. Okay, so mentioned that you can use custom models. So custom models are supported for the image labeling and object detection tracking APIs. So the MLKit exposes pretty easy to use high-level APIs for leveraging your own custom models, and it will support custom models from either TensorFlow, AutoML Vision Edge, or TensorFlow Light Model Maker. These all come from Google, so these are just 3 different ways of creating models using Google's tools, and all of these are compatible with MLKit. So if you want to use your own custom model or use a custom pre-trained model from recognized model creators such as Google, then you have these 3 options down here. So this is pretty much just repeating what I've just said, but you can use AutoML Vision Edge, which is offered through Google Cloud AI, and this allows you to create state-of-the-art image classification models. And then TensorFlow Lite Model Maker just allows you to retrain models essentially, or you can convert a model, a TensorFlow model into a TensorFlow Lite model, which is then compatible with MLKit. So that's pretty much the slideshows finished. So let me quickly take you in the last 5 or so minutes here into some live demos. So let me open up my TC26 here. I have. So the first thing I want to show you is this MLKit Vision set of APIs. So let me back out of here. So this is the standard demo that's available on GitHub. I'll have some links in the final slides here. And you can see there's different ways of demoing the functionality within MLKit. So you can use a live preview activity, a still image activity, and then you also have the option to use the Camera X APIs, and that's what we're going to go with now. So this starts up a live camera stream there. I've just got the phone sitting on my desk, so obviously it's pure blank right now. The first use case I want to show you is just facial detection. So if I choose that from the drop down now, and if I move my camera over this handily printed collection of faces here, we can see it performing the facial detection in real time for all of these different faces. These are all randomly generated faces, by the way, so these aren't real people, so no GDPR concerns or anything like that. And just to show this also happening in real time, I can show it with my face, and I can show my head moving around and still tracking me very comfortably. That looks slightly disconcerting. So that's the facial detection. Also wanted to show the pose detection. So this is in beta at the moment, so it's not 100%. We can see the legs start flickering there, but you can see it does detect the pose, which I think is quite interesting. Just a different way of using this software for more interesting use cases. Of course, we also want to do standard text recognition. So if I move this here, I have a printout of some UK driving license here. So unfortunately, it doesn't look amazing because the text is a little bit too large for you to read all of it. But hopefully towards the bottom, you can see the United Kingdom and driving license towards the top, as well as the UK and the old EU image there is all being detected live and in real time. And this is through the camera feed. We can also do the same sort of thing, but using dot codes on tires, for example. So we can see there, that's the dot codes being decoded. So obviously, because I can't keep my hand 100% still here, it's updating it quite frequently. But if I was to pass through a still image here, the results would be obviously more consistent. And the last thing I wanted to show you then is a separate demo. So this is using MLKit Vision APIs, but rather than just using their pre-made demo, this is using some Zebra hardware, which should hopefully put things into a bit more perspective. So one of the products we offer here at Zebra is called a HD 4000. So this is a heads-up display. This usually sits on a pair of glasses that would sit above your eye, and there's a little optical view here for the user to basically see what's going on without needing to use their hands. So this is kind of like Zebra's version of Google Glass. So if I plug this into my device here, and if I open up this HUD stock check demo, let the HUD be recognized as connected. Don't fail me now, live demo. Just give it a second. There we go. So the HUD has been connected. So the top view here is what's, sorry, this, there we go. The top view here is what is coming directly from the camera on the HD 4000. So we can see my presentation screen there. And then the bottom view is what's actually seen in this screen on the HD 4000. So if I go and hover this over a barcode here, this is using the MLKit barcode APIs to decode this barcode in real time using the camera from the HD 4000. And then it's just checking this. Apologies, I should have set the timeout to a little bit longer, but it's just using the APIs to decode that barcode and then check that against somewhere else. And we can see there that it's doing the stock check based on the barcode value. So I'm swiftly running out of time here, so I'm going to quickly bring everything to a close. It doesn't look like I have any questions. I noticed Udo there has put a question in regarding screen blur. I'm afraid I'm not sure what you're angling at there, but we have the links to the samples and the docs all available here, which should be in the presentations when they're sent out. So thank you very much. I think that's pretty much me bang on finished on time. I hope you enjoy the rest of the session. I hope you found this session useful. If any questions occur to you, please feel free to get in touch outside of this platform. Just get in touch with your local SE or try and find my email address from one of the organizers. I'll be happy to answer any questions. So thank you very much.